My name is Arno Semmelroth. I'm from Continental. You may know us as a tire company, but yes, we do also electronics and a lot of other things. And I'm particularly responsible for some of our growth fields. Growth fields are areas where we are dig in some new technologies, some new market opportunities, and like to learn what can we as a first tier do in that market. And I'm talking about smart mobility infrastructure. That means infrastructure for the mobility, particular for automotive mobility, but nevertheless, some of these things are also connected to other kinds of mobilities. And then we have the needs of communication. We already learned a lot about the challenges for communication in the automotive industry, and we will see that the infrastructure has also some of these challenges. What is the major infrastructure you may are aware of for automotive mobility? Yes, of course, it's the street. Unfortunately, the street is not usually so empty as in this picture, but may you have an idea, how long is the streets on this planet at the moment? What do you think? How many kilometers of streets do we have? Any idea from anybody? No idea at all? Do you believe it's less than 10 million kilometers? Less than 25 millions? No, less than 50 millions worldwide? 50 millions? So somebody believes more than 100 million? So you are a little bit shy to raise your hand. 100 million, that's good. That's a target. I would take that. Currently we have more or less on the planet 31.7 million kilometers of roads. So that's a lot. It's even more than we have cars to put on it, but that is the infrastructure. And this infrastructure is to be developed, has to be supported, and have even to give back information. We are looking for further driving, even on autonomous vehicles, and they have to understand, can I drive on that road? Is there enough information? Did I may not lose track if the sun is very bad, I only have a camera to see where to drive, and I lose the street. So infrastructure is not just the physical infrastructure, it's even the information about the infrastructure which we need in mobility. Beside the roads, we have invented signs. Sometimes it's more complicated to understand what is this sign's meaning for you on the road than just hitting the road. So there are signs limiting your driving. So information you have to take into account if you say how fast you want to drive. There's even information who is allowed to drive here. There's information where to drive to come to your target. Because that changed. It changed sometimes rapidly, but it changed at least over time. And you cannot only believe there's a road I'm allowed to drive. And last but not least, there are also information. Driving is one part of your vehicle, but parking another part. So you may have also seen that there's a potential parking available for you. So all this information about traffic signs, traffic situation, that is needed to make it happen. And that's the most static information. If we look one step ahead, we have dynamic information. So what is with the red light? What is with changing signs on the Autobahn? We already may have appeared today driving here out to Oberpfaffenhofen. So there is a lot of signs and information needed to drive safety. And you use our eyes, and may cars even have cameras to see that. But if the light is bad, if there's a problem, should that not be also a digital communication needed, that you get a precise information, or at least a second way of information so that you can determine is that right or wrong? And a red light not to seen or a red light not to taken care, that can be difficult. And there is another factor, there are more drivers on the road. It's not only drivers, it can even be pedestrians, it is public transportation, it's commercial vehicles, it's two-wheelers, and all of them want to use the same infrastructure in the same moment in time on the same place. So what is important? Important is that we get the necessary connection also to them to understand what they do, in which direction it goes, what they already know about the street to come, and the other factors of the infrastructure. Saying that, we're also looking in a bright future, and it's difficult to read that picture because it's so many on that. But as you see here, we will have pedestrians too on the road. A lot of them. And they are vulnerable road users, and we have to take care of them. We also see here that we will find new modes of transportation. There might be autonomous delivery of objects towards our location. There might be flying objects supporting us, delivering to us. There might be travel hubs where you change your mode of transportation. You want to know, can I park there? Did I reach my train? Are I on time? Can I make a more efficient route now by stopping here and go with the S-Bahn to Munich and not trying to find a parking lot in the inner city, which is a nightmare at some points on the time. So saying that, the infrastructure plays an important role of mobility at all, and the information about that is critical. And I looked up a little bit on an institute, which is the Gardner Group. They always make this kind of hype cycle, and you may have seen a lot of them. This is one about smart mobility. And you see they are still believing that there will be some autonomous mobility available. They see already some aviation on demand on the hype cycle high, which means the expectations are very high, but we are not really knowing how good that will work on the long run. Nevertheless, you also see here the intelligent connected infrastructure, which is an enabler, for a lot of technologies here on that cycle. And now we can really discuss how correct is that. That is from 2022. Usually they do it a few years. It was one of 21, and there will be some new one coming up, of course, maybe already this year. And then they change it and they say, okay, what's the timing behind that and how far can it get? You find topics like you already discussed 5G here, which comes up in 2 to 5 years for a global usage. Mm-hmm. But also you find technologies like 6G, where we still have a question, when will that be available? And the same, I think, is for the non-terrestrial networks. When will they be available? I heard out of the question it can take a long time until it is productive in the future. A lot of that is important for us. Why is it important? The smart infrastructure combines and communicates with each other and also to the user. At the end, it is usually pedestrians, it's people, it is public transportation, it is cars, which need this information to make a decision. To make a decision to drive safe, to make a decision to drive efficient, to make a decision to plan the route in a more intelligent way. And we already see the challenges today. I'm driving a car which has the problem that sometimes it runs out of the battery. And it's a nightmare in Germany to find a planning for my next charging station. Unfortunately, here I also can't charge. My car stays the full day, but it gets not charged. So what's the alternative? I have to drive back with the fuel, not with the battery. So my hybrid is out of energy. But that is the information. You need that as precise as possible. You have to blend that in your journey. And if you're thinking in a few years we only drive electric vehicles, it's more severe to make that happen. The same on other topics. We talked already about the traffic lights. We have the mobile applications we want on hand because there's our entertainment, there's additional information, but that can be combined. So if I know that there is a need, you have planned in to do something, and the infrastructure can supply you, there is an opportunity to fulfill that need, I can give you an information. We have the connectivity, we have the vulnerable road users, we have to protect. Safety is a critical issue where the infrastructure plays a key role. You know that we have more and more modes of transportation on the streets. There are more bicycles now on the streets, which were formerly occupied by cars, and the rate of accidents, unfortunately, is rising. The same for other modes of transportation. Micromobility can be a challenge in a safety situation because now this kind of mobility is much faster than the pedestrian we have expected in the past. So it would be very helpful to get the information up front and to react in the right way. Intersections are typical places where the accidents happen and have to be, from the infrastructure point of view, an opportunity to give additional information towards the vehicles what happens there. And last but not least, we have these easy topics like, where is the empty parking lot? I want to park my car because it makes no sense to arrive at a destination and then I have no way to step out. Talking about safety, this is a typical scenario. And you see it immediately. There's a person who makes a little bit wrongdoing. Anyhow, she crosses the road. And there's a vehicle, he has a green light of course, but he can't see it. Even with a perfect sensor, that is blocked. And that's a situation where typically the infrastructure comes into the game. The infrastructure can be another car who have visited that, or that we can enhance this intersection with sensoric. If the intersection already knows there is a person now crossing the road and this information is available, we can send out a message. We already have standardized this kind of messages so that the vehicle gets the warning there is somebody in your driveway. And that can be very helpful to prevent here an accident, at least to reduce the potential outcome of such an accident. And what happens here on an intersection can also happen on an entrance on a highway where is a wrong driving going on. That can happen in a lot of situations where micromobility happens, where you do a right turn and have missed to see the bicycle. A lot of that is tried by the automotive industry, particularly by the OEMs, to solve from a pure vehicle perspective. But there are limits. The infrastructure can fill up some of these holes, as the communication between the vehicles can fill up some of these holes. This is a typical example. The next step can also be that you get more information about what happens on your driveway. So is there an accident? Is there even a curve which you can easily take with a two-wheeler? And a two-wheeler is much more in danger if he drives the road and has some obstacle on the road than a classical four-wheeler or even a truck. So having that in mind, there is a lot of information about the surrounding, the way you want to go, which is not statically put in a map. It is dynamically. It is depending on the traffic situation, and we like to distribute that to you. And we have very difficult situations which can have a very fast decision process. So here's a picture shows you a little bit what can happen in this situation. There is a two-wheeler aside of your vehicle and the road is blocked. So what will happen now? Because you have to adapt your behavior on that. Particular autonomous vehicles have to adapt their behavior. And there's a certain chance that the two-wheeler slows down and follows you behind. I would personally say there's a much higher probability that he tries to pass you and go in front of you. And the same happens to other participants on the street. They can also change the lanes. And this is a process, of course, where an autonomous vehicle has to make a decision. Is it safe to stay there? Have I to slow down, maybe to give pass to this two-wheeler to prevent a critical situation on the street? And there's communication needed. Here we are with 30 milliseconds already in a critical phase. We have to have the turnaround side into my mind to have that happen. So it might be local communication works well, but is it available at the moment? Did we have a problem with that? Sometimes the network's breaking down. And even in a very critical situation, you may not get that information. So taking that into account, there is a lot of opportunities to increase safety if you can communicate about your own behavior and the situation around you. But that not only happens in cities. Look at such an area. And you would say, okay, I never drive there, but there is business. This is a mining situation where big business happens. They drill down the material we need for the future. And also they want to use the opportunity that infrastructure data, vehicle data, is available. There's at least two reasons. Here might be a danger zone where you want to be warned, because if there something happens, you only not have a personal issue if you are involved in an accident. That is a business issue. If you start such a mining only for an hour, that can be cost above 100,000 euro, even more, because they're living from that. So here is it really needed that the communication between all the participants here, the infrastructure, the vehicles, is guaranteed. And this network coverage, as we have learned, might be not guaranteed in such an environment. So here can really be a solution to have a better coverage. For me, it's not a request on a certain technology, but taking these factors into account. The coverage plays a big role. The quality of the communication plays a role. The bandwidth of the communication plays a role. The energy consumption of the communication plays a big role. And, as mentioned, the availability in such a construction site. If I go forward, I think it's already known. A lot of this technology has already evolved in the industry because we know that V2X communication plays a big role. And that involves infrastructure which distributes that. But that is the perfect setup only for a city environment. That does not happen everywhere. And it's already not happened on the 31.7 million kilometer on roads we have globally on this planet. So this is something in a high developed city. So you might find that here in a few cities already established very well, but it's not a global solution. Global solutions will have the industry to make even a business out of that, because that has to be functioning in Asia as it has to be function in Europe, as to have it function in the North Americas and also in the Near East and the Far East, because that is upcoming areas where business can be attached to that. And the cost of that is always a factor. So what we have discussed here is we have a perception. The infrastructure perceives situations on the different kind of technologies. Sometimes you have technologies which are on its own very low energy consumption. So there's inductive loops that nearly need a lot of energy. They even produce a little bit of energy to make the measurement. So if you want to have that information because it's important for the traffic flow somewhere else, you need also a communication technology which do not need a lot of energy. But that has to be taken into account. From our point of view, it makes a lot of sense to collect that information in the digital twin, a cloud-based solution where you can then make answers out of that. So knowing that there is a critical situation can help you to have a digital safety assistance preventing an accident, can help you to find your parking place. You have the autonomous valet parking as a function seen in the automotive industry, but in level 2 you need a lot of infrastructure information to make that happen. Now we can discuss will level 2 be important or will it be on a higher level, but level 2 is infrastructure-based autonomous valet parking, where you gather this data to combine that. You have all kind of infrastructure to vehicle communication, because the infrastructure knows a lot, you can be helped. You have the routing, dilemma zones, blind spots, that can be overcome with the infrastructure information. And here, around the digital twin, you need the communication in both directions. You need getting the sensor information and distribution the results. You also need a computation power. Sometimes you have a mobile edge computing to make that happen, to have the slow turnaround times. Sometimes the computation can be done elsewhere, and sometimes you have a little bit more time, particularly if you want to analyze a situation for a long time improvement by even changing the layout of the infrastructure for more safety. If we look about functions which might be coming with the non-terrestrial solutions, it can be ITS functionality. So can we have an emergency call from the infrastructure? The basic idea is that the infrastructure sometimes can see there happens an accident even if the vehicle is not connected, and the infrastructure can send out a warning call. We have the same with the traffic management. A lot of traffic management solutions, and even the first ones in the commercial areas, were satellite-based because in the US the coverage was very low. You have efficiency problems to increase. You can update the software on the sensors. With that, you have digital twinning, as we already discussed. And last but not least, the infrastructure can even be the source of an infotainment, so the information about what happens in the infrastructure, so that you get a buying opportunity, a resting opportunity, or information about a change on the mobility. Having said that, the hope is, of course, that we can have a connected mobility where autonomous vehicles as valid parking is a well-established solution based on the communication from the travel participants towards the infrastructure, and also safe driving for commercial vehicles, autonomous vehicles on the broad band of roads we have on this planet. We're only touching at the moment the opportunities of non-terrestrial networks. And it might be a second area, the infrastructure, where this can make a big difference because of one of the biggest advantages, the coverage, where we expect that this technology, the NTT, can cover much more than what we have currently. Nevertheless, at the end, the price plays the important role. The cost of such a solution will drive the potential use of that. Thank you very much.